Lesson 16, Average Speed. Objectives are first, to define the concept of speed. You'll also want to be able to tell the difference between what we mean by instantaneous and average speed, and to calculate the distance, speed, or time when given the proper information. Lastly, because speed can have a variety of different units, you want to be able to utilize the correct unit for a value. We start by taking a look at the difference between what we call speed and velocity. In everyday language, we use these words interchangeably, but in science, they have very specific meanings. Speed is the rate at which an object's distance changes. Velocity can have a more technical definition, but for us, the velocity is the speed as well as the direction in which an object is moving. So for example, if you were driving to hometown from school, we could say, and let's say you're going the speed limit, we could say that you're going 45 miles an hour up Hometown Hill. On the other hand, if we said that you were going 45 miles an hour northward, we would actually be giving the velocity. For our purposes, we're going to be concentrating on speed rather than velocity for simplicity of our calculations. Since speed and velocity are going to be calculated in very similar ways, the letter v is used to represent both speed and velocity in our equations. So v will be speed. There are two types of speed that we need to be concerned about. The first is what we call instantaneous speed, which is how fast something is moving at a given instant. So for example, if you're driving your car and you look at the speedometer is telling you how the rate at which your distance is changing at that instant. The average speed is how fast something is moving over a much larger period of time. Average speed is generally used for when you're moving at a more or less consistent speed over that time. We are going to focus on average speed for the remainder of this lesson and take a look at instantaneous speed in a later lesson. Since speed is a rate, our average speed is going to take on the form of a normal rate. Since it's the rate at which your distance is changing, our whatever is our distance, and we're going to be divided by time. We use a symbol of v with the subscripted a so that we know that we're talking about average velocity and not an instantaneous velocity. Note, v with the subscripted a stands for one thing. It is not v times a. And d is our distance, and t is our time. Since there are three things in our formula, we can use a triangle. And this triangle is going to be very useful, especially when we're solving for things like time. It makes the calculations much easier. Now, when you are doing something like driving in a car, your speed is going to be given in terms of things like miles per hour. Our basic units, though, in the MKS system are meters and seconds, and we would have something like meters per second. So because there are a lot of different types of units that can be used, you want to make sure that when you put values into an equation, that they have similar units. For example, that your time units are all the same. You can't mix hours and seconds. In the same way, you can't mix meters and miles. Let's take a look at an example. It says a person runs 6 miles an hour for 15 minutes. How far does the person run? We start off by identifying what we're looking for. How far? How far is giving us or asking for the distance. For this class, the only formula that you're going to be using that involves a distance is going to be the average speed formula. So we'll put that down. You can see that to find the distance, you need the average speed and you need the time. So our average speed is 6 miles per hour. Our time is 15 minutes. Now before we can substitute these values into our equation, we have to take a look at our units. Notice we have miles, hours, and minutes. We can't mix hours and minutes, so we need to convert 15 minutes into 0.25 hours. Now we can substitute our values in. If we use the equation, we're going to have to do a little bit of algebra in order to get the distance by itself. We have to multiply both sides of the equation by 0.25 hours. Notice in that case, when you multiply, the hours will cancel and we'll be left with miles. If we use the triangle, we can see that the 6 miles per hour and the 0.25 hours are right next to each other. So we'll be multiplying. We get a final answer of 1.5 and our unit is miles.